Okay, welcome you all for this continued session of this stiffness matrix, derivation of the stiffness matrix. In the previous video, we have derived the stiffness matrix, that is K is equal to integration of EI, where E is the Young's modulus, I is the moment of inertia, and C is the matrix. C is this matrix 4 by L square, dou square h1 by dou zeta square, dou square h2 by dou zeta square, dou square h3 by dou zeta square, dou square h4 by dou zeta square. What do you mean by dou square h1 by dou zeta square? We are differentiating this h1 equation twice. Differentiating this h1 is differentiating h1, it is dou h1 by dou zeta. Again differentiating it, it is dou square h1 by dou zeta square. Okay. Now you substitute all these C values and then transpose it, that is CT value. Substitute this C value and CT value in these equations, and simplifying you will get the stiffness matrix of the element. Okay, let us see here. Okay, this is H1, that is 1 by 4 into 2 minus 3 zeta plus zeta cube. Okay, differentiating this, we have dou H1 by dou zeta, there is no zeta sum, so differentiation of this 2 is 0. Next differentiation of this minus 3 zeta is minus 3. Next differentiation of this zeta cube, it is 3 zeta square. Okay, differentiation of this zeta cube, it is 3 zeta square. Okay, this is wrong, 2 will not come here. Okay, next differentiation of this equation, it gives you dou square h1 by dou zeta square. Okay, 1 by 4 as it is written, it is minus 3. There is no zeta term, so it is 0. Next we have 3 zeta square here, 2 is not there. Differentiation of 3 zeta square, it is 6 zeta. Okay, 6 zeta, 2 is not there, so it is 6 zeta by 4. 6 zeta by 4. Okay, similarly you find what is dou square h2 by dou zeta square, dou square h3 by dou zeta square, and dou square h4 by dou zeta square, and substitute in this matrix. Okay, then transpose it, that is CT matrix. Okay, substituting all these values, we have, see here, 6 zeta by 4, 6 zeta by 4, 6 zeta by 4, 2 is not there. Okay, then differentiate dou square h2 by, this is the value. Similarly dou square h3 by dou zeta, dou square h4 by dou zeta square. Okay, then this transpose of this matrix, it is CT. Okay, next what is taken here? Okay, multiplication of this matrix and this matrix. Okay, it gives 4 rows 1 column and 1 row 4 column, so you will get a 4 by 4 matrix. Okay, you simplify it. Then substituting this matrix, multiplication of CT and C matrix, and these are all constants. EI, LE by 2, it is constant. So integrating this CTC matrix, integrating means you are integrating to each value. 36 zeta, integration of 36 zeta square. What is the integration of zeta square in terms of zeta? It is 0. Okay, similarly you refer these three, okay, to find the values. Integration of zeta square, it is 0, so this term will be 0. Okay, so simplifying, substituting all the values and applying the limits, that is from minus 1 to 1. Already you know, when it is taken in terms of natural coordinate, in terms of minus 1 to 1. Okay, so integration of 36 zeta square divided by LE raised to 4, you will get 12. Okay, so finally this is the stiffness matrix for the beam element. Where L is the length of the element, EI divided by LE cube, and you have this 4 by 4 matrix, 12, 6 LE, 6 LE, 4 LE square, minus 12, 6 LE. Okay, this 4 by 4 matrix, this is the stiffness matrix for the beam element. Okay, thank you.